New surprise world transformation breakthrough battery to EV industry. Is it accurate to call advances in battery technology a breakthrough? They consist of breathless news pieces as well as grandiose declarations made by battery startup companies. The usage of the phrase breakthrough in connection with battery technology, however, is considered to be at best deceptive by a variety of experts, including scientists, engineers, company founders, and analysts. Is the recent development of solid-state batteries going to have a significant impact on electric vehicles? This innovation in solid-state batteries won't even be ready for production for a few more years, let alone be implemented in electric vehicles. It is still a very major step in the right direction, and automobile manufacturers will undoubtedly be paying careful attention to any subsequent advances that take place. Hey folks, welcome back to Tech Electric, where in today's video, we are going to discuss new EV battery breakthrough. But before we begin, make sure you subscribe to our channel and click on that bell icon so you don't miss out on any of our amazing videos. And let's begin! There is little doubt that Tesla is now the most well-known and technologically advanced manufacturer of fully electric vehicles. Since its release in 2012, the Tesla Model S has demonstrated that electric vehicles are capable of serving as practical daily and long-distance drivers, provided that there is a charging network that is both dependable and abundant. Before the release of the Model S, electric vehicles were generally considered to be better suited for use as city cars at best. It's astounding to see exactly how far battery technology has advanced, especially considering that the Model S is getting close to its 10-year anniversary. The most cutting-edge lithium-ion battery packs available on the market today offer a range that's somewhat greater than 500 kilometers. However, here's the problem with all technologies: they progress, and Samsung has recently revealed that they've made a breakthrough in battery technology. To be more precise, we are talking about solid-state batteries, which are the kind of batteries that can solve many of the problems that are associated with electric vehicles. An investigation was undertaken by scientists from the Samsung Advanced Institute of Technology and the Samsung R&D Institute of Japan. They started by removing the lithium metal anodes that are typically present in solid-state batteries and then replacing them with a layer that was made of silver and carbon composite. The research group found that by doing so, the battery was able to sustain a bigger capacity, a longer life cycle, and an improvement in overall safety. Additionally, the layer of silver carbon is just 5 micrometers thick, but it contributes to an increase in the total energy density of the material. The so-called pouch that the team developed would have a lifespan of more than 1,000 recharges and would extend the range of an electric vehicle to around 500 miles. To put it another way, a battery can power an electric vehicle for up to 500,000 kilometers. Additionally, solid-state batteries have charge speeds that are even quicker than the most advanced lithium-ion batteries available today. If you are an enthusiast and want to learn more about EVs, then please check out our channel where you'll find really amazing content, and consider subscribing for more amazing content in the upcoming future. The one and only drawback: this innovation in solid-state batteries won't even be ready for production for a few more years, let alone be implemented in electric vehicles. It is still a very major step in the right direction, and automobile manufacturers will undoubtedly be paying careful attention to any subsequent advances that take place. It is possible that Samsung's finding will be a watershed moment in the development of electric vehicles and batteries, provided that more testing and development go according to plan. The increasing demand for electric vehicles in the United States has shed attention on the substantial challenges associated with acquiring the battery technology necessary for the broad transition to renewable energy and away from fossil fuels in a manner that is environmentally responsible. The increasing popularity of electric cars and other systems that store energy has put a spotlight on the batteries that are utilized in these many applications. These applications are dominated by lithium-ion batteries, and the materials that are necessary to produce them are in extremely high demand. In addition to lithium, these batteries may also contain nickel, manganese, and cobalt as some of their primary components. Since sulfur is an abundant element that can be mined in methods that are both safe and helpful to the environment, it has been considered for a considerable amount of time to be an appealing option for use in lithium-based batteries. Because of irreversible chemical interactions between intermediate sulfur compounds and the electrolytes, previous attempts to develop lithium batteries using sulfur cathodes and the typical carbonate electrolytes used in lithium-ion batteries were unsuccessful. These interactions prevented the combination of sulfur cathodes and carbonate electrolytes. Every once in a while, incredible new technologies materialize out of thin air to radically alter our environment. The invention of dynamite, penicillin, X-ray machines, and even microwave ovens are all examples of breakthrough discoveries that were made by accident. It's possible that there was another one this year. On the other hand, this time it is anticipated that not only will it alter the way in which we live, but it could also perhaps save our globe from catastrophic climate change by unlocking an elusive technology known as lithium-sulfur batteries. We have spent the better part of the last several decades searching for the most advanced technology that can support our contemporary way of life, while also facilitating the development of environmentally friendly technologies such as electric automobiles. Since the early 1990s, lithium-ion batteries have been considered the superior technology for use in batteries. It is used to power anything from mobile devices and electric cars like Tesla's to energy grid backup systems and even rockets. In spite of the fact that they brought us into the 21st century, they have a number of major flaws that need to be addressed. To begin, the mining process for the components that are required to construct them, such as cobalt, is frequently quite harmful to the surrounding ecosystem. They cause chaos in huge ecosystems and can leak substances that are detrimental to the environment. In addition, there's a humanitarian problem because some of these mines have hazardous working conditions and employ children. The problem of life also has to be addressed. We anticipate that our devices will have speedier charging periods. This is true for a wide range of products from mobile phones to vehicles. On the other hand, as the owner of a smartphone will attest to you, lithium-ion batteries quickly lose their capacity if consistently charged at a high rate. The deterioration of batteries is a big issue, particularly in the electric vehicle business. If the battery dies in a used electric vehicle, the vehicle may be useless because replacing it might be expensive. Overall, this is a barrier to the widespread adoption of electric vehicles and portends a worsening of the problem of electronic waste, which is already a significant concern. There's also the problem of density to consider. Although lithium-ion batteries have a high energy density, despite their weight size and bulkiness, they are nevertheless very cumbersome to use. Because the batteries are so heavy, electric cars have a limited range, and the batteries are inappropriate for a variety of purposes, such as commercial electric planes and ships. Electric cars have a restricted range because the batteries are so heavy. Additionally, there's a risk of fire when using lithium-ion batteries, since a broken cell can spontaneously catch fire and burn quite strongly. Think about what happened to some of the older Samsung phones, like the Note 7 and the Rimac electric vehicle that Richard Hammond wrecked. Because of this, researchers at Drexel University were looking into an entirely new kind of battery called a lithium-sulfur battery. They found a technique to integrate sulfur into lithium-ion batteries with startling effects, in the hopes of developing batteries that not only perform better than those that are now used in EVs, but are also constructed from components that are readily available. Since the industry that makes batteries for electric vehicles is currently concentrating its efforts on the development of new battery technologies using lightweight multifunctional materials, it's possible that we'll observe a significant improvement in the market for electric vehicle batteries in the years to come. Hey, that's going to do it for today's video, friends. We sincerely hope you enjoyed it. If you did, make sure you please give it a like and share it with your friends and family. And let us know if you have any questions for us in the section below. Don't forget to subscribe to our YouTube channel to see more of our incredible videos. We look forward to seeing you in our next one. Hey, thanks for watching and have a great day.